Hello and welcome to this video lesson on charge clouds. It has specification reference 3.1.3.5. And in this video lesson we're going to understand the concept of charge clouds first of all, so that we can explain the difference in bond angle created by a lone pair, that's a pair of electrons not involved in a covalent bond, and another pair of electrons that is involved in a covalent bond, and they would be called a bonding pair. So the angle that exists between bonds depends on whether it's a lone pair of electrons or a bonding pair of electrons. So we're going to explain that difference. So let's first of all look at charge clouds and see what we mean by charge clouds. And in order to do that, let's use the ammonia molecule. The ammonia molecule NH3. And the reason why we're picking ammonia is because it has a lone pair and it also has three covalent bonds. So the version of ammonia that you'll be familiar with, the dot and cross diagram of ammonia that you're familiar with, we're going to draw out quickly now. And we've done this very recently. So we've got one nitrogen atom surrounded by three hydrogen atoms. And then let's draw the ammonia electrons in blue. Let's make them blue crosses. So nitrogen is in group 5 outer electrons. So there's 1, there's 2, there's 3, and we have a lone pair of electrons, 4 and 5. So that's the nitrogen electrons. The hydrogen, let's make hydrogen red crosses. So each hydrogen has 1 electron. There they are. And so you can see now we've got 3 covalent bonds between the nitrogen and the 3 hydrogens, and we've got 1 lone pair. And that's how we've been drawing it so far. But you'll know from your physics that electrons aren't really particles, and you'll also know that you can't really say where an electron is going to be. All you can say about where an electron is going to be is that it has a higher probability of it being in one place than another place. And if you look at these bonds here, these electrons here rather, all you can say is that there is a higher probability that those 2 electrons are going to be between this hydrogen atom and this nitrogen atom than anywhere else. So that area where we've drawn them is just the area where there is the highest probability that those electrons will be at any instant in time. When you study in physics your quantum theory, that's where you'll learn that. So that brings us on to charge clouds. So let's redraw now this nitrogen atom, ammonia molecule. We're going to draw the nitrogen atom here, and actually we're going to draw the 3 hydrogen atoms here. Now let's just remind ourselves that at the middle of the atoms there's a nucleus, and we're going to make these the nucleus, and I'm just going to draw a positive charge just to remind us that we've got a positive charge in the nucleus. So first of all I'm going to draw this pair of electrons, a charge cloud for this pair of electrons. So let's put them there as blue crosses, all right, as per before. But what we can say is that the area where they are most probably found, right, is a sphere that I've drawn as a circle. Is a sphere like that, and it's sort of spherical shape because that's where they are, and it's not being stretched or pulled by any other forces. So that's the lone pair that we've accounted for, and we've drawn an area of probability where they're most likely to be found, and we're going to call that area of probability where they're most likely to be found, we're going to call that a charge cloud. So a charge cloud is an area of probability where the electrons are most likely to be found. And this particular charge cloud of a lone pair is a spherical shape that we've drawn as a circle on our sheet of the screen. Now let's secondly do this. Let's do this pair of electrons here. And so we've got a blue cross, which was the nitrogen's electron, and a red dot that was the hydrogen's electron. And now we're going to draw in green our charge cloud, and this time I'm going to draw it as a sort of elongated sphere, sort of oval shape, like that. And you can see that it would be a sphere like the lone pair, but it's being pulled towards the hydrogen nucleus by the positive charge of that hydrogen nucleus, the proton there. So it's been pulled into a more elongated shape. And the other bonding pairs are just the same. So we're going to draw our other bonding pairs like this. There's our bonding pairs of electrons, and then the shape of the charge cloud is that sort of oval shape, like that, because it's been pulled towards the hydrogen a little bit by the electrostatic force of the positive hydrogen nucleus. So what you also know about electrons, and therefore charge clouds, is that they are negative. And so one charge cloud is going to repel another charge cloud. And the question is, do they all repel each other equally? And the reason you ask that question is because the answer is no, they don't repel each other equally. These spherical charge clouds of lone pairs repel, because of their shape, they're going to repel a bonding pair, which is oval shaped. They're going to repel more than the bonding pair of electrons. So if we go back to our first diagram of ammonia, and you have to remember that in reality this is 3D. So if we had nitrogen in the middle, like this, and we would represent this line to be our bonding pair of electrons, and then you would have 3D sort of pyramid shape for the covalent bonds to the hydrogen atoms. You might expect all these bond angles to be the same, right? The way that we've drawn it first. All those bond angles would be the same, and if they were the same, they'd be, remember it's 3D, they'd be 109 degrees. But they're not like that, because there is more repulsion. So the repulsion between these charge clouds is greater than the repulsion between these clouds here because of their shape. You can see because of their shape they can get a bit closer together before they're too close. And this angle here is going to be the same as this angle is going to be the same as this angle, right? And this angle here is going to be the same as this angle here, but there's going to be more repulsion here and here than there is between here and here. So that distorts the bond angle, and that's why I drew the hydrogen atoms not at right angles like in the first diagram. So in fact what the bond angle becomes is, if we just draw it again, the bond angle becomes this, and we're talking about this bond angle here, which is the same as this bond angle here. This becomes 107. and I just have to correct a mistake on the previous slide. The 109, and it's 109.5, is this angle here, and of course this angle here. So whereas it would be 109.5 if all these bonds were equally repelled from each other, they're not equally repelled, so the repulsion here is more. So this bond angle becomes bigger, and the angle between the nitrogen and the hydrogens, the angle between covalent bonds becomes smaller. It's gone from 109.5 to 107. And this concept of bond angles depending on the shape of the charge cloud is called the valence shell electron pair repulsion theory. Snappy name, eh? So what we're going to do is we're going to go into that a little bit deeper and summarize it on the next slide by looking at a water molecule. So just to remind you what valence means, the valence shell is just the outer shell. Electron pair you know, and we're talking about the repulsion between either lone pairs and other lone pairs, or the repulsion between lone pairs and bonding pairs, or in fact the repulsion between two bonding pairs. So we're going to just compare those three options of magnitude of repulsion by looking at a water molecule, as we said. Now, you will have seen me writing out a water molecule quite often in class, and you'll therefore remember that it's not a horizontal line. The two bonding angles are not 180 degrees. We in fact draw them at an angle like this. So let's draw our electrons in. Start with the bonding electrons. So we know that let's make hydrogen electrons our red dots. Right, so this hydrogen electron is going to quite often find itself there and there. And oxygen, group 6 outer electrons. Let's make oxygen's electrons blue crosses. Right, so it's going to let one of its electrons, its unpaired electrons, be involved in each covalent bond, but it's still got 4 other electrons that are paired up, and so we're going to draw those as pairs like that. Okay, so now we're going to draw in our charge clouds. And let's start off with our lone pairs at the top, and lone pairs, as you know, have spherical charge clouds, right, because they're not being pulled away by any other positive charge. And our bonding charge clouds are more oval in shape. Sorry, very wonky ovals. And so now we've drawn in our charge clouds with their shapes, and now we can think about bond angles and compare the 3 options that we mentioned at the start. So we want to consider 3 different types of bond angle. We want number 1, let's call that the bond angle. So bond angle, let's write it up here so I don't have to keep writing it. Bond angle between, this is a lone pair and a lone pair. Yeah, this number 2, this bond angle here is between the lone pair and the bonding pair. And this bond angle here, 3, is between 2 bonding pairs. And all the valence share electron pair repulsion theory is a statement of relative bond angles between these three different types of bond angles. Okay, so let's have a think. So let's look at number one. We're going to have an angle between two lone pairs. Number one is the bond angle between two lone pairs. Now they're spherical, so they're going to push each other apart the most. So this bond angle is going to be greatest, right? Because the repulsion is greatest. And this is bond angle. Let's skip over to bond angle 3. Bond angle 3 is going to be the least because the repulsion between those two oval-shaped charge clouds is going to allow them to get closer together, so that bond angle is going to be the least. Because the repulsion is least, which allows the bonds to get close to each other. And so this, number 2, the angle between a lone pair and a bonding pair is going to be the medium bond angle. So that finishes our video lesson. Just a quick one this time. So do we now understand the concept of charge clouds? Just the area where an electron is most probably going to be found. And we represent that by a sort of shaded area. And now I think we can explain the difference in bond angle created between lone pairs and bonding pairs. So just to recap the valence shell electron pair bonding theory, we've got lone pair bond angle is going to be greater than lone pair bonding pair, which is again greater than bonding pair bonding pair. That is the valence shell theory. So we're done. Hope that's been clear.